Encyclopedia of Supply Chain Management, Concepts, Strategies, and Operations. Front matter. Preface. The global supply chain is the central nervous system of the modern world economy. It is a complex, dynamic, and interconnected web of activities that transforms raw materials into finished products and delivers them to the end consumer. In recent years, the critical importance of robust, resilient, and agile supply chains has been thrown into sharp relief by global pandemics, geopolitical tensions, climate events, and rapid technological change. What was once a behind-the-scenes operations function is now a core strategic priority in boardrooms worldwide. This encyclopedia was conceived to provide a comprehensive, authoritative, and accessible reference for anyone navigating this vast field. Whether you are a student encountering these concepts for the first time, a seasoned practitioner seeking to deepen your expertise in a specific area, or an executive making strategic decisions, this volume is designed for you. Our goal is to bridge the gap between foundational theory and practical application. The entries within these covers not only define key terms and concepts but also explore their real-world implications, challenges, and evolving best practices. The content is structured to guide the reader logically from the core principles of supply chain management, Part I, through its essential operational functions, Part II, to the technologies that enable it, Part III, and the cross-cutting themes that define its modern context, Part IV. We conclude by looking forward to the trends that will shape the future of global trade and logistics, Part V. We are immensely grateful to the diverse collective of academics, industry experts, and thought leaders who have contributed their knowledge to this project. It is their insights that ensure this work is both academically rigorous and genuinely practical. We hope this encyclopedia becomes a well-used resource on your desk, providing clarity and insight as you engage with the ever-evolving, fascinating world of supply chain management. The editor's city, date - list of contributors. This encyclopedia is the product of a collaborative effort by leading minds in supply chain management. Our contributors include Dr. Evelyn Reed, Professor of Supply Chain Logistics, name of University Chapters, Demand Planning and Forecasting, Inventory Management. Michael Chen, SCORP, Senior Vice President of Global Sourcing, name of Multinational Corporation Chapters, Sourcing and Procurement, Supplier Relationship Management. Sarah Jones, Founder and CEO, name of Logistics Tech Firm Chapters, Emerging Technologies, Data Analytics and Visibility. Professor David Miller, Director of the Center for Transportation Studies, name of University Chapters, Logistics and Distribution Management, Transportation Management. Maria Garcia, CPA, CMA, Head of Supply Chain Finance, name of Manufacturing Firm Chapters. Financial Aspects of SCM. Ben Carter, Principal, name of Consulting Firm Chapters, Supply Chain Strategy and Design, Risk Management and Resilience. Dr. A.I. Tanaka, Lead Researcher, name of Research Institute Chapters, Sustainability and Ethics, Circular Economy. Additional names and affiliations would be listed here to fill out the roster. How to use this encyclopedia. This volume is designed for multiple uses, as a linear text, a conceptual reference, and a problem-solving tool. 1. Linear study, for students and those new to the field. The encyclopedia is structured to be read from Part I through Part V, building knowledge from foundational concepts to advanced strategies. 2. Topical reference, for practitioners seeking information on a specific topic. Use the detailed table of contents or the comprehensive index at the back of the book to locate precise concepts, terms, and models. 3. Conceptual exploration, within each chapter, key terms are bolded at their first significant mention. Cross-references to other relevant entries within the encyclopedia are indicated with a small superscript arrow, northeast arrow, and the relevant chapter or section number, allowing you to explore interconnected concepts easily for practical application. Most chapters include real-world case studies, brief examples illustrating how concepts are applied in actual business scenarios. Key formulas, boxed sections containing essential calculations, e.g., EOQ, forecast error metrics. Further reading, curated lists of academic papers, books, and articles for those who wish to delve deeper into a subject. 5. Appendices, the back matter contains a glossary of key terms, a collection of common formulas, and a case study compendium for quick review and application. Chapter 1 of the Encyclopedia, based on the provided outline. Part I, Foundations of Supply Chain Management. Chapter 1, Introduction to Supply Chain Management. Chapter Overview. This chapter provides the fundamental framework for understanding supply chain management, SCM. It defines SCM, traces its historical evolution from a logistical function to a strategic imperative, and introduces its core components. The chapter establishes why SCM is critically important to the global economy and outlines the primary objectives that guide its design and execution. 11 Definition and evolution of SCM. Definition: Supply chain management is the active management of supply chain activities to maximize customer value and achieve a sustainable competitive advantage. It represents a conscious effort by an organization to develop and run supply chains in the most effective and efficient ways possible. A supply chain encompasses all activities associated with the flow and transformation of goods from raw materials to end user, as well as the associated information and financial flows. Evolution: 1960s to 1970s, physical distribution and materials management. The focus was on isolated functions like warehousing, transportation, and inventory management within a single firm. The concepts of physical distribution, outbound, and materials management, inbound, were separate. 1980s, logistics integration. The integration of inbound and outbound logistics into a single logistics management function gained traction. The goal was to optimize costs across these previously siloed activities within the organization. 1990s, birth of supply chain management. The term supply chain management emerged. The perspective expanded beyond a single company's walls to include suppliers and customers. The focus shifted from mere cost reduction to improving coordination and reducing time across the chain. Key drivers were globalization and the rise of enterprise resource planning, ERP, systems. 2000s, globalization and collaboration. SCM became a core strategic function. The era was defined by complex global networks, outsourcing, and emphasis on visibility and collaboration with partners using advanced technologies. 2010s present, the digital, resilient, and sustainable supply chain. The current era is defined by the adoption of digital technologies, AI, IoT, blockchain, a heightened focus on building resilience against disruptions, and the integration of sustainability and ethical considerations as non-negotiable elements of supply chain strategy. 12 The 5 core components: plan, source, make, deliver, return. This framework, often associated with the supply chain operations reference score model, breaks down SCM into 5 primary management processes. 1. Plan, the strategic layer of SCM. This involves developing a strategy to balance demand and supply to meet sourcing, production, and delivery requirements. It includes demand forecasting, inventory planning, and developing metrics to monitor the supply chain's performance. 2. Source, the process of procuring goods and services needed to create a product. This involves selecting suppliers that can deliver the required items at the best value, negotiating contracts, ordering materials, receiving shipments, and managing supplier relationships. Supplier relationship management, SRM. 3. Make, the manufacturing or production step. This involves scheduling activities necessary for production, testing, packaging, and preparing goods for delivery. It encompasses all transformational activities and is where lean manufacturing principles are applied. For deliver, also known as logistics. This encompasses all processes related to order management, warehousing, transportation management, and delivering the finished product to the customer. A key system here is the Warehouse Management System, WMS. 5. Return, the reverse logistics process. This involves managing all returns of defective, excess, or end-of-life products from customers, including receiving, verifying, disposing, recycling, or exchanging returned items. An efficient return process is critical for customer satisfaction and cost recovery. 13 The importance of SCM in the global economy. Supply chain management is the backbone of global commerce. Its importance is multifaceted: driver of economic growth. Efficient supply chains enable trade, reduce the cost of goods, and make products accessible worldwide, fueling economic development and lifting living standards. Source of competitive advantage, companies no longer compete as independent entities but as supply chains. A superior supply chain, e.g., faster, more reliable, more cost-effective, provides a significant market advantage over rivals. Enabler of globalization, SCM makes it possible to source raw materials from one continent, manufacture in another, and sell to consumers in a third, optimizing for cost, quality, and speed. Impact on consumer experience, SCM directly determines product availability, delivery speed, and cost, key factors in customer satisfaction and loyalty. In the age of e-commerce risk management, modern supply chains are exposed to myriad risks: natural disasters, geopolitical issues, pandemics. Effective SCM is the first line of defense in identifying, mitigating, and recovering from these disruptions. 14 Key objectives: efficiency, responsiveness, and resilience. These three objectives form a strategic triad that guides all supply chain decisions. There are inherent trade-offs between them, and a chain's design must reflect the specific priorities of the business and its customers. 1. Efficiency, cost-effectiveness. The traditional objective of minimizing costs across the supply chain. This includes reducing inventory holding costs, transportation costs, and production costs. It is the primary goal of lean strategies. 2. Responsiveness, customer-oriented. The ability to respond quickly to customer needs and changes in demand. A responsive supply chain prioritizes speed and flexibility over pure cost minimization. It is the primary goal of agile strategies. 3. Resilience, risk-prepared. The capacity to anticipate, adapt to, and recover from disruptions. This involves building flexibility, redundancy, and visibility into the supply chain to withstand shocks and maintain operations. This objective has become paramount in the wake of recent global disruptions. A fast fashion retailer prioritizes responsiveness, a cement manufacturer prioritizes efficiency, and a pharmaceutical company producing essential medicines must build resilience. The most advanced supply chains strive to excel in all three areas. Chapter 2 of the Encyclopedia. Based on the provided outline. Part I, Foundations of Supply Chain Management. Chapter 2, Supply Chain Strategies and Design. Chapter Overview. This chapter delves into the strategic choices that define a supply chain's structure and capabilities. It begins with the principle of strategic fit, ensuring the supply chain's goals support the overall business strategy. It then explores the primary supply chain strategies: lean, agile, and the hybrid legal approach. The chapter concludes with critical design decisions regarding network configuration, outsourcing, and geographic sourcing. 21 Strategic fit, aligning SCM with business strategy concept. Strategic fit requires that the competitive strategy of a company and the capabilities of its supply chain are perfectly aligned. The supply chain must be designed to best meet the needs of the target customer segment. Framework, understanding customer needs. Functional products, staples, e.g., toothpaste, canned food, with stable, predictable demand and long life cycles. They require a cost-efficient supply chain. Innovative products, fashion items or new electronics with unpredictable demand, short life cycles, and high variety. They require a responsive supply chain. The implied demand uncertainty, the gap between a product's supply and demand profiles, determines the level of uncertainty. High implied demand uncertainty, common with innovative products, requires a responsive supply chain. Low uncertainty, common with functional products, requires an efficient supply chain. Achieving fit, the supply chain must achieve strategic fit by ensuring its capabilities in efficiency and responsiveness match the implied demand uncertainty of the products it serves. A mismatch like a highly efficient supply chain for a high fashion product leads to stockouts or excessive markdowns. 22 Lean supply chain strategies. Objective, to eliminate all waste, including time and cost, to create a highly efficient, low-cost supply chain. Key principles: waste reduction, identifying and eliminating MUTA, non-value-added activities, in processes. Pull-based system, production and distribution are driven by actual customer demand, not forecasts. This is epitomized by just-in-time, JIT, inventory systems. Continuous improvement, Kaizen, a culture of constantly seeking small, incremental changes to improve efficiency and quality. High utilization, focus on maximizing the utilization of assets and resources to spread fixed costs. Best for functional products with predictable demand, high volume, and low variety, e.g., groceries, basic commodities, bulk chemicals, example, Toyota Production System, TPS-23 Agile Supply Chain Strategies Objective, to be responsive and flexible to meet rapidly changing customer needs and to capitalize on volatile markets. Key principles: responsiveness, the ability to react quickly to changes in demand or supply; flexibility, designing processes and systems that can adapt to changes in product mix and volume; postponement, delaying product differentiation, e.g., final assembly, customization, until as close to the customer order as possible; information driven, relying on shared, real-time data across the supply chain to enable quick decision-making; best for innovative products with unpredictable demand, short life cycles, and high contribution margins, e.g., fashion, popular consumer electronics, example, Zara's fast fashion model, which can design, produce, and deliver new garments to stores in weeks. 24 Legal, hybrid, strategy concept, a hybrid approach that seeks to leverage the strengths of both lean and agile strategies. The supply chain is lean up to a certain point, the decoupling point, and agile after it, the decoupling point. This is the point in the material flow where product specification occurs. Upstream from this point, the processes are forecast-driven and lean, producing standardized components or base products. Downstream from this point, processes are order-driven and agile, performing customization and final assembly based on actual customer demand. Best for products that have a base element with stable demand but require significant customization, e.g., computers, hard drives and processors are built lean, while final configuration is agile. Automobiles, base models are built to forecast, while premium trims are built to order. 25 Supply chain network design definition, the process of structuring a supply chain to determine the optimal number, location, size, and role of facilities, plants, distribution centers, warehouses, and the flow of materials between them. Key decisions: facility role, what is the function of each facility, e.g., production, storage, cross-docking. Facility location, where should facilities be placed based on factors like proximity to suppliers/customers, labor costs, taxes, and infrastructure. Capacity allocation, how much capacity should be allocated to each facility and product line. Market allocation, which markets or customer regions will each facility serve. Objective, to minimize total system cost, including transportation, inventory, and facility costs, while meeting service level requirements and mitigating risk. Modern network design also heavily factors in resilience and sustainability. 26 Outsourcing vs insourcing, make vs buy decisions. Definition, the strategic choice between performing a supply chain activity in-house, insourcing, or contracting it to an external third-party specialist. Outsourcing pros, allows a firm to focus on its core competencies, can provide access to specialized expertise and technology, converts fixed costs into variable costs, offering flexibility potential for significant cost reduction due to economies of scale. Outsourcing cons, loss of direct control over the process and quality, potential for higher long-term costs, risk of exposing proprietary knowledge, increased complexity in coordination and communication. Insourcing pros, greater control, protection of intellectual property, and potentially better coordination. Insourcing cons, requires significant capital investment and may dilute management-focused decision factors, core competency, cost, control, risk, and capacity. 27 Offshoring, nearshoring, and reshoring, these are specific types of outsourcing/insourcing decisions related to geographic location. Offshoring, relocating a business process, e.g., manufacturing, to another country, typically to leverage lower labor costs, often involves long distances and complex global logistics, e.g., manufacturing in Asia for a U.S. market. Trade-off, lower cost vs higher transportation cost, longer lead times, and greater risk. Nearshoring, a form of offshoring where the process is moved to a nearby country, often one that shares a border or is in the same region, e.g., a U.S. company moving manufacturing to Mexico or Eastern Europe for a European company. Trade-off, Slightly higher cost than offshoring but with benefits of shorter lead times, lower transportation costs, and easier management due to similar time zones and often trade agreements. Reshoring, or onshoring, the process of returning business operations to the company's original country. Drivers, the total cost of offshoring, including hidden costs of risk, quality, and freight, becomes less favorable. A desire for greater control, political incentives, and the need for speed and responsiveness. The COVID-19 pandemic significantly accelerated reshoring trends. Chapter 3 of the Encyclopedia, based on the provided outline. Part I, Foundations of Supply Chain Management. Chapter 3, Supply Chain Integration and Collaboration. Chapter Overview. This chapter addresses the critical challenge of coordinating activities across independent organizations within a supply chain. It begins by exploring the detrimental bullwhip effect, a primary consequence of poor coordination. It then examines structural strategies like vertical and horizontal integration before detailing collaborative processes such as CPFR and VMI. The chapter concludes by underscoring the fundamental human and legal elements, trust and contracts that underpin all successful collaboration. 31 The Bullwhip Effect, Causes and Mitigation. Definition. The bullwhip effect is a distribution channel phenomenon where order volatility amplifies as one moves upstream in the supply chain, from retailer to distributor to manufacturer to supplier. Small fluctuations in consumer demand create increasingly large swings in orders placed upstream, leading to inefficiencies like excess inventory, poor capacity utilization, high transportation costs, and lost revenues. Key causes. 1. Demand forecasting. Updating. Each member of the chain bases its forecasts and orders on the demand from its immediate downstream customer, not the end consumer, compounding errors at each step. 2. Order batching. Companies order in large, infrequent batches to minimize ordering costs or to qualify for volume discounts, creating a lumpy demand pattern for suppliers. 3. Price fluctuations. Special discounts and forward buying during price promotions cause customers to buy in large quantities they don't immediately need, creating artificial demand spikes. For rationing and gaming. When product supply is limited, suppliers may ration based on order size. Anticipating this, buyers inflate their orders to secure more stock. When supply normalizes, these inflated orders are suddenly cancelled. Mitigation strategies. Share information, provide all supply chain partners with access to real-time point-of-sale (POS) data to see true customer demand. Align incentives, move away from practices that encourage gaming, like price promotions and volume-based quotas. Implement everyday low pricing (EDLP), reduce order batching, streamline ordering processes to reduce associated costs, enabling smaller, more frequent orders. Collaborative planning, work with partners on shared forecasts and replenishment plans. CCPFR 33-32. Vertical and horizontal integration. These are two strategic models for owning and controlling parts of the supply chain. Vertical integration, the degree to which a firm owns its upstream suppliers. Backward integration, and its downstream customers. Forward integration, example, backward a car manufacturer acquiring a tire company. Example, forward a coffee roaster opening its own chain of cafes. Pros: greater control over supply/demand, secured access to inputs or channels, capture of profit margins from adjacent stages. Cons: high capital investment, reduced flexibility, potential for lower efficiency due to lack of competitive pressure. Horizontal integration, the process of acquiring or merging with competitors at the same stage of the supply chain. Example, one airline company acquiring another. Pros: increased market share, economies of scale, reduction in competitive intensity. Cons: antitrust/regulatory scrutiny, organizational culture clashes, and the challenge of managing larger, more complex operations. The modern trend has been away from ownership, integration, and toward coordination and collaboration with independent partners. 33 Collaborative planning, forecasting, and replenishment. CPFR definition. CPFR is a formalized business practice where supply chain partners jointly plan key activities from production and delivery of products to end consumer demand. It is a structured 9-step process designed to create a single, shared forecast and plan for the entire supply chain, the CPFR process. Overview 1. Front-end agreement. Partners agree on objectives, scope, and rules of engagement. 2. Joint business planning. Share company strategies and define category roles. 3. Sales forecasting. Create a shared forecast of consumer demand. 4. Order planning/forecasting. Forecast order and shipment requirements. 5. Order generation. Conversion of forecasts into firm orders. 6. Order fulfillment. Execution of the order, production, shipping, delivery. 7. Exception management. Identifying and resolving discrepancies between plans and actual performance. 8. Performance assessment. Tracking key metrics to evaluate the collaboration's success. Benefits. Significantly reduced bullwhip effect, improved forecast accuracy, higher service levels, reduced inventory, and stronger partner relationships. 34. Vendor managed inventory, VMI. Definition: a collaborative inventory management strategy where the supplier, vendor, assumes responsibility for maintaining the inventory levels at the customer's distribution center or store. The supplier has access to the customer's inventory and sales data and makes restocking decisions based on agreed upon service levels. How it works: 1. The customer provides the supplier with real-time access to sales and inventory data. 2. The supplier monitors inventory levels and forecasts demand. 3. The supplier initiates shipments to maintain predetermined inventory levels at the customer's location. 4. The customer is typically billed only after the inventory is sold. Consignment, or used benefits, for the customer, reduced administrative costs, guaranteed stock availability, and improved inventory turns for the supplier, better visibility into demand, more efficient production planning, and strengthened customer relationships for the supply chain, reduced overall inventory, smoother product flow, and better alignment of supply with consumption. A classic example is the relationship between Walmart and Procter & Gamble. 35. The role of trust and contracts in collaboration. Successful collaboration is not just a matter of process and technology, it is fundamentally a human endeavor built on a foundation of trust and formalized by contracts. The role of trust, information sharing. Partners are more willing to share sensitive data, e.g., real-time sales, cost structures, if they trust it won't be misused. Flexibility. Trust allows partners to adapt to unforeseen changes without resorting to costly renegotiations or litigation. Joint problem solving. A trusting environment fosters a mindset of "we're in this together" when problems arise, rather than a blame game. Long-term orientation. Trust encourages investment in relationship-specific assets and processes with a longer payback period. The role of contracts. Framework for collaboration. Contracts provide the essential legal and operational framework, defining roles, responsibilities, performance metrics, KPIs, and data sharing protocols. Risk allocation. They clearly outline how risks, e.g., demand volatility, cost changes, are shared between partners. Incentive alignment. Well-designed contracts include gain-sharing or performance-based clauses that incentivize both parties to improve the overall supply chain's performance, not just their own safeguard. Contracts serve as a necessary safeguard and a clear course of action if the collaboration breaks down or trust is breached. The most effective collaborative relationships strike a balance where a strong contract enables and protects the trust that is built over time through successful interactions. Chapter 4 of the Encyclopedia, based on the provided outline. Part 2, Core Functions and Processes. Chapter 4, Demand Planning and Forecasting. Chapter Overview. This chapter covers the critical process of predicting future customer demand, which serves as the foundational input for all other supply chain activities. It explores the various techniques for forecasting, from qualitative judgments to sophisticated quantitative models. The chapter also details how to measure forecast accuracy and introduces the essential cross-functional business processes S&OP and IBP that translate a forecast into an executable operational plan. 41 Forecasting techniques, qualitative and quantitative. Demand forecasting methods fall into two broad categories, often used in combination. A qualitative techniques definition. Subjective methods based on expert judgment, intuition, and opinion used when historical data is limited or irrelevant, e.g., new product launches, entering new markets, during periods of high volatility, Key methods: market research, using surveys, focus groups, and other market testing techniques to gauge customer interest. Delphi method, a structured process where a panel of experts anonymously provides forecasts and justifications, which are then shared and refined over multiple rounds to achieve a consensus. Salesforce composite, aggregating the forecasts of individual sales representatives based on their knowledge of customers and territories. Executive opinion, a group of high-level executives meet to develop a forecast based on their experience and knowledge of the broader market. Quantitative techniques. Definition, objective methods that use historical data and statistical models to identify patterns and project them into the future, used when past data is reliable and trends are expected to continue. Key methods, explored in detail in 42 and 43, time series analysis, projects future demand based solely on past demand patterns. Causal models, uses identified relationships between demand and other external factors, e.g., economic indicators, marketing spend, to forecast demand. 42 time series analysis, this approach decomposes historical demand data into its core components to identify a pattern for projection. Components of time series data: level, the baseline, average demand around which the data fluctuates; trend, the consistent upward or downward slope of the data over a long period; seasonality, a repeating pattern of spikes and troughs that occurs over fixed, regular intervals, e.g., weekly, quarterly, yearly, cycle; longer term, non-fixed fluctuations often related to business or economic cycles, e.g., the housing market cycle; random noise, the unexplainable, irregular variation that remains after the other components are removed. Common time series models, naive approach, the forecast for the next period is simply the actual demand from the current period, useful as a baseline for comparison. Simple moving average, SMA, the forecast is the average demand over a specified number of recent periods. Smoothens out random noise. Weighted moving average, WMA, similar to SMA, but assigns different weights to past periods, often giving more weight to recent data. Exponential smoothing, a sophisticated technique that uses a weighted average of past data, with the weights decaying exponentially for older observations. It is highly effective and widely used. Key variants include: simple exponential smoothing, for data with no trend or seasonality; Holt's method, for data with a trend; Holt-Winters method, for data with both trend and seasonality. 43 causal models. Definition, also known as associative models, these techniques assume that the factor being forecasted, the dependent variable, has a cause and effect relationship with one or more other factors, independent variables. The most common causal model is linear regression. Formula, $y equals a plus bx $, where $y is the forecasted demand, dependent variable, $x is the independent variable, e.g., GDP, advertising budget, price, $a is the y-intercept, $b is the slope of the line, representing the change in y for each unit change in x. Application, a company might use regression to forecast sales, $y, based on its television advertising spend, $x. Multiple regression can incorporate several independent variables, e.g., price, competitor activity, economic indicators, other. Causal techniques include econometric modeling and simulation. 44 measures of forecast error, MAD, MSE, MAPE. Since all forecasts are wrong, measuring the error is crucial for improving forecasting processes and setting appropriate safety stock levels. Mean absolute deviation, MAD, the average of the absolute differences between the forecasted and actual values. Interpretation, measures the average size of the forecast error in units. Easy to understand. Mean squared error, MSE, the average of the squared differences between the forecasted and actual values. Interpretation, penalizes larger errors more significantly than MAD. Useful for comparing different forecasting models. Mean absolute percentage error, MAPE, the average of the absolute differences between the forecasted and actual values, expressed as a percentage of the actual values. Interpretation, the most common metric as it is relative and easy to communicate, e.g., our forecast is off by an average of 5%. Using these measures, forecasters use these metrics to 1. Select the best model. Compare the error metrics of different models applied to historical data. 2. Monitor ongoing performance. Track error over time to ensure the forecasting process remains accurate. 3. Set safety stock. The measure of error, typically MAD or standard deviation, is a direct input into safety stock calculations. 45. Sales and operations planning, S&OP. Definition: a monthly integrated business management process where the executive leadership team reviews, aligns, and synchronizes every function of the company: sales, marketing, finance, operations, and supply chain around a single, unified operating plan. The classic 5-step S&OP process: 1. Data gathering and forecasting. Update the demand forecast for the next 18 to 36 months. 2. Demand planning. The sales and marketing team reviews the forecast and creates a consensus demand plan. 3. Supply planning. The operations and supply chain team creates a plan to meet the consensus demand plan, identifying any constraints, e.g., capacity, material shortages. 4. Pre-S&OP meeting. Functional managers reconcile differences between the demand and supply plans and develop scenarios and recommendations for executive review. 5. Executive S&OP meeting. The leadership team makes cross-functional decisions to balance supply and demand, aligns the plan with financial goals, and authorizes the final integrated plan goal, to ensure the tactical plans in all departments are aligned and support the overall strategic business plan. 46. Integrated business planning, IBP. Definition: the evolution of S&OP. IBP is a more comprehensive and strategic process that fully integrates the operational plan with the financial plan and corporate strategy. It is often considered S&OP done right. Key differences from S&OP. Feature: S&OP IBP scope: tactical, operational, strategic, enterprise-wide focus, balancing supply and demand, integrating operations, finance, and strategy. Finance role informed at the end, integrated throughout the process. Time horizon 18 to 36 months, 24-36 plus months, rolling output and operational plan of financially backed, strategy aligned business plan. IBP incorporates a deeper financial analysis, longer-term strategic considerations, and a tighter link to product management, portfolio planning, and risk management. It is the process that truly enables an organization to manage the business rather than just manage sales and operations. Chapter 5 of the Encyclopedia, based on the provided outline. Part 2, Core Functions and Processes. Chapter 5, Sourcing and Procurement. Chapter Overview. This chapter moves from planning to execution, focusing on the acquisition of goods and services essential for production and operations. It distinguishes between the tactical function of procurement, processing orders, and the strategic function of sourcing, developing supply channels. The chapter outlines the formal strategic sourcing process, methods for selecting and managing suppliers, the critical importance of ethics in global trade, the role of digital platforms, and the comprehensive financial analysis of total cost of ownership. 51. Strategic sourcing process. Definition: strategic sourcing is a systematic, fact-based approach for optimizing an organization's supply base and improving the overall value equation. It goes beyond simple price negotiation to analyze what is being bought, who it is being bought from, and how it is being bought. The 7-step strategic sourcing process. 1. Profile the category. Understand the spend category: what is being purchased, in what volumes, from whom, and at what cost. Segment spend using a portfolio analysis, e.g., Kroljic matrix. 2. Supply market analysis. Research the supply market for the category. Identify key suppliers, market trends, cost drivers, and innovations. 3. Develop the sourcing strategy. Based on the profile and market analysis, decide on the sourcing approach. This could involve negotiation, competitive bidding, supplier consolidation, or exploring alternative materials. 4. Select the sourcing process. Execute the strategy through a formal process like a request for information, RFI, request for proposal, RFP, or request for quotation, RFQ. 5. Negotiate and select suppliers. Conduct negotiations not just on price, but on terms, quality, delivery, payment, and partnership opportunities. Select the supplier, that offer the best overall value. 6. Implement agreements, transition to the new supplier. This involves finalizing contracts, setting up systems, and communicating changes to internal stakeholders. 7. Benchmark and manage performance, continuously monitor supplier performance against agreed upon key performance indicators, KPIs, and the contract. Foster continuous improvement. 52. Supplier selection and evaluation. Choosing the right supplier is a critical decision that impacts cost, quality, risk, and innovation. Supplier selection criteria, cost and value, price, but also consideration of payment terms and total value delivered. Quality, ability to consistently meet specifications and quality standards, e.g., ISO certifications, delivery performance, on-time delivery record and logistical capabilities. Financial stability, the supplier's financial health to ensure they will be a viable partner. Long-term technical capability and capacity, possession of the right technology and enough capacity to meet current and future demand. Risk profile, location, political stability, labor practices, and cybersecurity. Posture evaluation methods, supplier surveys and questionnaires, to gather standardized information. Financial analysis, reviewing credit reports and financial statements. Site audits and visits, first-hand assessment of facilities, processes, and quality systems. References, checking with the supplier's other clients. Trial orders, testing performance with a small order before full commitment. 53. Supplier relationship management, SRM, definition. SRM is a comprehensive approach to managing an enterprise's interactions with the suppliers that provide the goods and services it uses. The goal is to move from adversarial transactions to collaborative relationships that unlock mutual value. Key principles, supplier segmentation, not all suppliers are equal. The Kroljic matrix is a classic tool for categorizing suppliers based on profit impact and supply risk, which dictates the relationship style. Strategic suppliers, high risk, high impact, collaborate deeply through partnerships and joint development. Leverage suppliers, low risk, high impact, use competitive bidding to exploit purchasing power and negotiate the best price. Bottleneck suppliers, high risk, low impact, mitigate risk by securing supply, seeking alternatives, or holding safety stock. Routine suppliers, low risk, low impact. Streamline the ordering process to minimize administrative costs, e.g., through e-procurement catalogs, joint business planning, working with key suppliers on shared goals, innovation and continuous improvement projects. Performance management, regularly reviewing scorecards based on KPIs like on-time delivery, OTD, quality and cost. 54. Global sourcing and ethics. Global sourcing, procuring goods and services from international markets across geopolitical boundaries driven by cost advantages, access to unique capabilities, and qualified suppliers. Key ethical and operational considerations, labor practices and human rights, ensuring suppliers do not use child labor, forced labor, and provide safe working conditions, e.g., adhering to SA 8000 standard. Environmental stewardship, assessing the environmental impact of the supply chain and ensuring compliance with regulations. Anti-corruption, adhering to laws like the Foreign Corrupt Practices Act, FCPA, to prevent bribery and corruption. Transparency and traceability, knowing where products and materials come from to verify ethical claims and comply with regulations, e.g., conflict minerals, legal compliance, navigating complex international trade laws, customs, tariffs, e.g., Incoterms registered trademark rules, and sanctions frameworks. Many companies adopt codes of conduct for suppliers and use third-party audits to ensure compliance. 55. E-procurement and digital platforms. Definition, the use of internet-based technology to automate and streamline the key procurement processes, from requisition to payment. Key components of an e-procurement system, e-sourcing, online RFP/RFQ auctions and bid management. Supplier portals, online hubs for supplier communication, documentation, and performance tracking. E-requisitioning and catalogs, online, pre-approved catalogs where employees can shop for goods, enforcing compliance with negotiated contracts. E-ordering, electronic transmission of purchase orders to suppliers. E-invoicing and payment, automated processing and payment of electronic invoices, often matching them to POS and receipts benefits, reduced process costs, improved compliance, enhanced spend visibility, faster cycle times, and stronger data for analysis. 56 Total cost of ownership, TCO, definition, a comprehensive financial assessment that estimates all direct and indirect costs associated with acquiring, using, and maintaining a good or service from a particular supplier, over its entire life cycle purpose. To move beyond the simplistic focus on purchase price and make sourcing decisions based on the true cost, which often reveals a different low-cost supplier. TCO components include, acquisition price, the base price paid to the supplier, ordering costs, costs of processing orders, transportation and logistics, quality costs, costs of inspection, rework, scrap, and warranties, downtime costs, costs of production delays caused by late or defective deliveries, inventory costs, costs of carrying, safety stock and cycle stock, capital, storage, risk of obsolescence, risk costs, costs associated with supply disruption, geopolitical instability or compliance failures, end-of-life costs, costs of disposal or recycling. By calculating TCO, a company might find that a supplier with a slightly higher unit price but superior quality, delivery, and reliability offers a significantly lower total cost. Chapter 6 of the Encyclopedia, based on the provided outline. Part 2, Core Functions and Processes. Chapter 6, Manufacturing and Operations. Chapter Overview. This chapter delves into the core transformation processes within the supply chain. The make function. It explores the strategic choices in production design, from how a product is configured to meet demand to the philosophies that guide efficiency and flow on the plant floor. It covers the critical tasks of planning capacity, scheduling work, and, most importantly, ensuring the highest levels of quality are engineered into every process. 61 Production Strategies, MTS, ATO, MTO, ETO. These strategies define the point in the process at which a product is linked to a specific customer order, creating a crucial trade-off between efficiency and responsiveness. They exist on a spectrum from make to stock to engineer to order. Make to stock, MTS. Description: products are manufactured and held in inventory before a customer order is received. The order is then fulfilled from finished goods. Stock driver: efficiency and cost effectiveness for high volume, predictable demand. Key challenge: accurate demand forecasting is critical to avoid stockouts or excess inventory. Example: consumer packaged goods, toothpaste, canned food, basic apparel. Assemble to order, ATO/make to order, MTO. Description: ATO standardized components and sub-assemblies are produced and held in inventory. A customer order triggers the final assembly or configuration of the product from these modules. Description: MTO. The product is manufactured after the customer order is received. Raw materials or generic components may be held in stock, but the final product is unique to the order driver. Responsiveness and customization while controlling inventory costs. This is a classic legal strategy, with the decoupling point at assembly. Example: ATO Dell computers, assembled from standardized parts. Example: MTO Boeing commercial aircraft, highly customized, long lead time, engineered to order. ETO. Description: the product is designed, engineered, and manufactured after the customer order is received. Often, the product is unique and requires new design and sourcing. Driver: maximum customization for highly specialized, low-volume products. Key challenge: managing complex projects with long lead times and high uncertainty. Example: specialized industrial machinery, naval ships, custom architectural structures. 62 Lean manufacturing and just-in-time, JIT. Lean manufacturing is a holistic philosophy and set of principles focused on creating more value for customers with fewer resources by eliminating waste. MUTA, the 7+1 wastes, Timwood. Transportation: unnecessary movement of materials, inventory, excess raw materials, WIP, or finished goods. Motion: unnecessary movement of people, waiting, idle time between processes, overproduction, producing more than is needed. The worst waste: overprocessing, using more effort than is value added. Defects: effort spent correcting mistakes, skills. Underutilizing employee talent and creativity. The eighth waste just in time, JIT, is a core component of Lean. It is a production strategy that aims to improve ROI by reducing in-process inventory and associated carrying costs. Components arrive at the assembly line exactly when they are needed and in the exact quantity required. Key enabler of JIT, the Kanban system, a visual signaling method, e.g., a card or bin, used to trigger the movement or production of material in a pull-based system. 63 Theory of Constraints, TOC. Definition: a management philosophy introduced by Eliyahu M. Goldratt that states that any manageable system is limited in achieving more of its goals by a very small number of constraints. The 5 focusing steps, process of ongoing improvement. 1. Identify the system's constraint, S, the bottleneck. 2. Exploit the constraint, S, ensure it is never idle and is working only on what it should. 3. Subordinate everything else to the above decision, align the entire system to support the constraint's efficiency. 4. Elevate the system's constraint, S, if needed, invest in increasing the constraint's capacity. 5. Repeat the process. Once a constraint is broken, identify the next one. Avoiding inertia. Application. TOC provides a powerful framework for prioritizing improvement efforts. Increasing the throughput of the constraint increases the throughput of the entire system. 64 Capacity planning and management. Definition: the process of determining the production capacity needed by an organization to meet changing demands for its products. Levels of capacity planning: long range, 1-year strategic decisions about facilities, major equipment, and overall capacity levels. Medium range, 3 to 18 months aggregate planning to match output to forecasted demand by adjusting workforce size, output rates, and inventory levels. Short range, 3 months detailed scheduling and allocation of specific jobs to specific machines and work centers. Key metrics: design capacity, the maximum output rate under ideal conditions. Effective capacity, the maximum output rate under normal, real-world conditions, e.g., considering maintenance, breaks, utilization, equals, actual output/design capacity. 100% efficiency, equals, actual output/effective capacity. 100%. 65 Shop floor control and scheduling. Shop floor control, SFC, is the set of systems and processes for managing the flow of materials and information on the plant floor to execute the production plan. Key functions of SFC: loading, assigning work to work centers. Sequencing, determining the order in which jobs will be processed at a work center. Detailed scheduling, assigning specific start and end times to each job. Monitoring, tracking the progress of jobs against the schedule and reporting on status. Common scheduling approaches: Gantt charts, visual scheduling tools. Finite vs infinite loading, scheduling with or without consideration of capacity constraints. Priority rules, rules like first come, first served, FCFS, earliest due date, ED, or shortest processing time, SPT, to determine job sequence. 66 Quality management, TQM, Six Sigma, total quality management, TQM. A comprehensive, organization-wide effort to instill a permanent culture of continuous improvement in quality and customer satisfaction. It involves all employees and transcends the quality department principles: customer-focused, total employee involvement, process-centered, integrated system, strategic and systematic approach, continual improvement, fact-based decision-making, communication. Six Sigma, a disciplined, data-driven methodology for eliminating defects and reducing variation in any process goal. Achieve a process so capable that it produces only 34 defects per million opportunities. DPMO, methodology: DMAIC, define, measure, analyze, improve, control, for improving existing processes. DMADV, define, measure, analyze, design, verify, for creating new processes or products. Infrastructure, led by champions, master black belts, and green belts who are experts in the statistical tools and methods relationship. TQM provides the overarching cultural philosophy for quality, while Six Sigma provides a specific, Powerful toolkit for achieving quality objectives. Chapter 7 of the Encyclopedia, based on the provided outline. Part 2, Core Functions and Processes. Chapter 7, Logistics and Distribution Management. Chapter Overview. This chapter addresses the critical deliver function of the supply chain. It covers the physical movement and storage of goods from the end of production to the point of consumption. The chapter explores the management of transportation networks, the technology and design principles behind modern warehouses, the intricacies of fulfilling customer orders, especially the challenging last mile and the often overlooked but vital process of handling returns through reverse logistics. 71 Transportation Management, Modes: Air, Rail, Road, Sea, Intermodal. Definition: the strategic management of the movement of goods from origin to destination. It involves selecting the best modes, carriers, and routes to balance cost, speed, and reliability. The 5 primary modes of transport: 1. Air. Advantages: greatest speed for long distances, high security, reduces inventory carrying costs. Disadvantages: highest cost, limited capacity, subject to weather/air traffic delays, significant carbon footprint. Best for high value, low weight, time-sensitive goods, e.g., electronics, pharmaceuticals, emergency shipments. 2. Road, truck. Advantages: high accessibility, point-to-point delivery, flexibility, speed for short to medium distances, frequent departures. Disadvantages: higher cost than rail or sea, subject to traffic and road conditions, capacity constraints, regulatory limitations, e.g., hours of service. Best for short haul, regional distribution, and last mile delivery. Dominant mode for freight in most economies. 3. Rail. Advantages: high capacity for heavy/bulky goods, cost effective for long distances, energy efficient, good for weather resistant storage. Disadvantages: lack of flexibility, fixed tracks, slower transit times, potential for congestion at terminals, requires truck transport for first/last mile. Best for heavy bulk commodities, coal, grain, chemicals, intermodal containers. Overland. 4. Sea, water. Advantages: lowest cost per unit, enormous capacity for non-perishable goods, essential for global trade. Disadvantages: slowest speed, subject to port congestion and weather, requires land transport on both ends, complex documentation. Best for high volume, low value, non-time sensitive goods in international trade, e.g., raw materials, furniture, consumer goods. 5. Pipeline. Advantages: highly reliable and specialized, low cost per unit for suitable products, continuous movement. Disadvantages: extremely inflexible, fixed route, one product type, high initial capital investment, limited to liquids, gases, and slurries. Best for oil, natural gas, water, and chemical products. Intermodal transportation, the use of 2 or more modes of transportation in a single journey, with the product transferred between modes in a standardized container. The most common combination is ship-rail-truck. This leverages the cost-effectiveness of rail/sea for the long haul and the flexibility of trucks for the first and last mile. 72 Warehouse Management Systems, WMS. Definition: a software application designed to support and optimize warehouse functionality and distribution center management. It provides real-time visibility into inventory and streamlines every step of the warehousing process. Core functions of a WMS: inventory management, tracks every item by lot, serial number, and location within the warehouse in real time. Receiving and put away, directs staff on where to store incoming goods for optimal space utilization and picking efficiency. Order picking and packing generates optimized pick lists and routes, e.g., batch picking, zone picking, to minimize travel time. Guides packing processes shipping, manages dock door scheduling, creates shipping labels, and generates bills of lading and advanced shipping notices. ASNs, labor management, tracks employee productivity and helps manage workloads. Reporting, provides data on key metrics like inventory accuracy, on-time shipments, and warehouse capacity. Benefits: dramatically improved inventory accuracy, increased space utilization, reduced labor costs, faster order fulfillment, and enhanced customer satisfaction. 73 Warehouse layout and design. The physical design of a warehouse is crucial for efficient material flow and space utilization. Key design principles: straight line flow. Design the layout so that product flows in a straight line from receiving, storage, picking, shipping to avoid backtracking and cross-traffic. Velocity-based storage. Place high turnover, fast-moving SKUs in the most accessible locations, e.g., near the packing/shipping area, to minimize picker travel time. Slower moving items can be stored in higher or more distant locations. Zone picking, dividing the warehouse into zones where pickers are responsible for a specific area. Orders are passed between zones to complete fulfillment. This specializes labor and reduces travel but requires coordination. Cross-docking, a technique where incoming goods are unloaded from a supplier truck and directly loaded onto outbound customer trucks with minimal or no storage in between. This reduces handling and inventory holding costs but requires highly coordinated scheduling and predictable demand. 74 Order fulfillment and last mile delivery. Order fulfillment, the complete process from receiving a customer order to delivering the product to the customer's door. It includes picking, packing, shipping, and delivery. The last mile delivery, the final and most critical and often most expensive step of the delivery process, getting the package from a local distribution center to the end consumer. Last mile challenges: high cost, can account for 50% plus of total shipping cost due to low drop size, traffic congestion, and failed delivery attempts. Customer expectations: demand for fast, same day/next day, free and transparent delivery. Urban logistics, challenges of delivering in dense urban areas with parking and access restrictions. Innovative solutions: micro-fulfillment centers, MFCs, small warehouses located in urban areas to enable faster delivery. Locker/parcel station delivery, delivering to a secure, automated locker for customer pickup. Crowdsourced delivery, using platforms like UberRush or DoorDash for flexible delivery capacity. Route optimization software, algorithms that create the most efficient delivery routes for drivers. 75 Inventory management within the warehouse. This focuses on the specific practices for managing stock within the four walls of the warehouse, supporting the broader inventory management strategy. Cycle counting, an ongoing inventory auditing procedure where a small subset of inventory is counted on a specific day without stopping warehouse operations. This maintains high inventory record accuracy and replaces disruptive full physical inventory. Slotting, the process of determining the optimal storage location for each product within a warehouse based on its size, weight, demand, velocity, and compatibility with other products. Effective slotting maximizes space and efficiency. ABC analysis, classifying inventory into three categories, A, B, C, based on their value or turnover rate. A items, high value, fast moving, receive the most management attention and prime storage locations. 76 Reverse logistics and returns management definition, the process of planning, implementing, and controlling the efficient, cost-effective flow of raw materials, in-process inventory, finished goods, and related information from the point of consumption back to the point of origin for the purpose of recapturing value or proper disposal. The returns management process: 1. Gatekeeping, authorizing and validating the return at the point of entry. 2. Receiving and sorting, inspecting the returned item and determining its condition. 3. Disposition decision, deciding the most profitable path for each item, restock, return to sellable inventory, if unopened/new, refurbish/remanufacture, repair and resell, often in a secondary market, liquidate, sell in bulk to a third party. Donate, for tax benefits. Recycle, recover raw materials. Landfill, as a last resort for return processing, executing the disposition decision, e.g., issuing a refund. Repackaging, strategic importance, an efficient reverse logistics process is a major competitive advantage in e-commerce, directly impacting customer loyalty and a company's sustainability profile. It can turn a cost center into a value recovery center. Chapter 8 of the Encyclopedia, based on the provided outline. Part 2, Core Functions and Processes. Chapter 8, Inventory Management. Chapter Overview. This chapter addresses one of the most critical and costly elements of supply chain management, inventory. It explores the various reasons for holding stock, the costs associated with it, and the fundamental quantitative models used to optimize inventory levels. The chapter provides the tools to balance the competing goals of product availability and cost efficiency, detailing how to classify inventory for effective management and how to calculate the safety stock needed to achieve a desired service level. 81 The role of inventory, cycle, safety, seasonal, decoupling. Inventory exists to buffer misalignments between supply and demand. Different types of inventory serve specific roles. Cycle stock, the portion of inventory that is depleted and replenished cyclically as customers order the product. It is the inventory that is built up when a large order is received and then used up until the next order arrives. Its size is directly determined by the order quantity, e.g., the EOQ. Safety stock, buffer inventory held to protect against uncertainty in demand, demand variability, and supplier lead time variability. It prevents stockouts caused by unexpected spikes in demand or delays in replenishment. Seasonal stock, inventory that is built up in anticipation of predictable, seasonal increases in demand, e.g., holiday decorations, winter clothing, sunscreen for summer. This allows a company to maintain a level production schedule throughout the year. Decoupling stock, inventory held between different stages of a production process or supply chain to allow each stage to operate independently. This work in process, WIP, inventory decouples machines or processes, so a breakdown at one stage doesn't immediately shut down all upstream and downstream operations. 82 Inventory costs, holding, ordering, shortage. Effective inventory management requires understanding and balancing these three fundamental costs: holding, or carrying, cost, the cost to hold one unit of inventory for 1 year. This includes capital cost, the opportunity cost of money tied up in inventory, storage costs, warehouse space, utilities, insurance, handling costs, labor to move inventory, risk costs, obsolescence, spoilage, theft, depreciation, typically expressed as a percentage of the item's value, e.g., 20 to 30% per year, ordering, or setup, cost, the cost associated with placing an order or setting up a production run, regardless of the order size. This includes administrative costs, processing purchase orders, invoices, transportation costs, if not dependent on quantity, production changeover costs, labor and lost capacity to reconfigure equipment, shortage, or stockout cost, the cost incurred when demand exceeds available inventory. This includes lost sales and profit margin, back order costs, additional paperwork, special shipping, expediting, loss of customer goodwill, and future business. Hard to quantify but extremely significant. The goal of inventory models is to minimize the sum of these costs. 83 Economic order quantity, EOQ, models definition. The economic order quantity, EOQ, is the ideal order quantity a company should purchase to minimize its total inventory costs, holding and ordering costs. It is one of the oldest and most well-known classical production scheduling models. The EOQ formula, $EOQ equals \SQRT \frac 2DSH $, where D equals annual demand, units. S equals ordering cost per order, H equals holding cost per unit per year, Assumptions of the basic EOQ model: demand is known, constant, and continuous. Lead time is known and constant. Receipt of inventory is instantaneous and complete. Quantity discounts are not possible. The only variable costs are ordering and holding costs. While these assumptions are rarely perfectly true, the EOQ model is remarkably robust and provides a strong starting point for determining a reasonable order size. 84 Reorder point, ROP, model's definition. The reorder point, ROP, is the specific level of inventory at which a new order must be placed to replenish stock before a stockout occurs. It is calculated to cover demand during the lead time. The ROP formula, under certainty, $ROP equals D \times L, where D equals average daily demand, L equals lead time in days. The ROP formula, under uncertainty, with safety stock, $ROP equals D \times L plus SS, where SS equals safety stock. This formula ensures that an order is triggered when there is just enough inventory left to cover average demand during the lead time, plus an extra buffer, safety stock, to account for variability. 85 ABC analysis and cycle counting. These are two key techniques for efficiently managing a large number of SKUs. ABC analysis, Pareto principle, a method of classifying inventory into three categories based on its value and importance. A. Items, high value, 20% of SKUs, 80% of dollar value. Tightest control, most frequent reviews, detailed records. Low safety stock, but highly managed. B. Items, medium value, 30% of SKUs, 15% of dollar value. Moderate control, less frequent reviews. C. Items, low value, 50% of SKUs, 5% of dollar value. Simplest controls, large order quantities, high safety stock, periodic reviews. This approach allows managers to focus their time and effort on the items that have the most significant impact on overall inventory costs. Cycle counting, an ongoing inventory auditing procedure where a small subset of inventory is counted on a specific day. It replaces the disruptive annual physical inventory and maintains high record accuracy. How it works: counts are scheduled regularly, e.g., daily,